Welcome to this explainer. Today, we're diving straight into how the refining and marketing industry measures, manages, and reports on the extreme dangers of their day-to-day operations. We'll be looking at this through the lens of the SASB standards. That's the Sustainability Accounting Standards Board. It's a fascinating, highly structured framework that shows us exactly how companies handle everything from a single worker's injury to a catastrophic facility failure. Okay, let's just jump right in. Right off the bat, you have to ask yourself, how do you actually measure safety when your entire business relies on highly reactive chemicals, intense heat, and massive pressure? I absolutely love starting with this question because it sets the visceral stakes of the environment we're looking at today. We aren't talking about paper cuts in an office here. We're talking about massive industrial complexes where the baseline condition is, frankly, incredibly hazardous. The way a company manages these stakes tells you a whole lot about its operational efficiency and its long-term viability. Here is our roadmap for today. We'll cover high-stakes refining hazards, tracking workforce health, critical incident risk management, loss of primary containment, and finally, building a safety culture. Let's start with part 1, high-stakes refining hazards. Before we can even begin to evaluate safety data, we have to ground ourselves in what workers in this industry are facing on the ground every single day. The baseline hazards here pose immense daily risks. You've got the processing of high-temperature and high-pressure hydrocarbons, and you're handling some highly flammable, extremely volatile substances. When you mix reactive chemicals with intense pressure and heat, the risk for things like fires or chemical exposures is literally ever-present. A failure in this environment doesn't just mean a delay in production, it can result in severe injuries, illnesses, or, tragically, fatalities. Plus, if these substances get out, the danger spilled right over into neighboring communities. So managing these hazards is absolutely crucial. It's not just about ticking a regulatory box, it is about protecting human life and preventing massive operational downtime. Moving on to part 2, tracking workforce health. So knowing those physical hazards, how do we actually monitor everyday occupational safety? How do we turn a vague goal like staying safe into hard, reportable data? Well, you really need to understand a few key metrics that capture everything from a close call to a fatality. Under the SASB standards, companies have to report on 3 main rates. First, the total recordable incident rate, or TIR. This covers injuries or illnesses bad enough to result in days away from work, restricted work, or medical treatment beyond just a basic first aid kit. Then there's the fatality rate, which is, well, exactly what it sounds like. And finally, the near-miss frequency rate, or NNFR. A near miss is basically a situation where an unplanned event didn't hurt anyone or damage anything, but under slightly different circumstances, it easily could have. And here's the kicker. SASB requires companies to log these rates not just for their direct employees on the payroll, but for the contract workers on site too. Now, you might be wondering how we compare a massive global refinery to a much smaller one. That's where this number comes in, 200,000. It's a constant used to calculate all of these safety rates. Why 200,000? Well, it actually represents the total number of hours that 100 full-time workers working 40 hours a week for 50 weeks a year will provide annually. By multiplying the incident count by 200,000 and then dividing by the total hours worked, we standardize the data. It's a really clever way to ground the abstract math in actual human lives, putting facilities of totally different sizes on a completely equal playing field. All right, Section 3, Critical Incident Risk Management. Let's zoom out from the individual worker for a second and look at the macro level. There is a huge critical difference between a localized accident and an emergency that causes major downtime and threatens a whole community. Think of it this way. If a worker trips and breaks an arm, that is an occupational safety issue, obviously bad, but localized. But if a highly pressurized pipe bursts and releases toxic gas into the atmosphere, that is a process safety event, or PSE. Process safety is essentially all about keeping the hazardous materials inside the pipes and tanks exactly where they belong. Which leads us perfectly into Section 4, Loss of Primary Containment. To really analyze process safety and understand those major system failures, we have to grasp the anchor concept behind them, loss of primary containment, or LOPC. Put simply, LOPC is just the technical term for dangerous leak, spill, or explosion. And notice how the definition states any material. That means even an uncontrolled release of high-pressure steam, hot condensate, or compressed air counts. If it is an unplanned release from where it's supposed to be safely contained under normal operating conditions, it's an LOPC. That right there is the triggering event for a major process safety event. Now, the industry actually categorizes the severity of these events into tiers based on consequence. A Tier 1 process safety event is basically the worst-case scenario, an LOPC of the greatest consequence. Look at the thresholds here. We are talking about events that lead to a fatality, a community evacuation, a shelter-in-place order, or a massive fire resulting in at least $100,000 in direct costs to the company. A Tier 2 event is an LOPC of lesser consequence. It's still serious for sure. It might result in a recordable injury or fire damage over $2,500, but it hasn't quite reached the catastrophic level of a Tier 1 disaster. Logging the rates of these Tier 1 and Tier 2 events gives us an incredibly stark, clear picture of a facility's macro-level safety. But what about when the disaster doesn't happen, but it got way, way too close for comfort? That brings us to Tier 3 events. These are known as challenges to safety systems. Basically, these are instances where there was a real flaw or weakness in the internal safety systems, but the consequences ultimately fell below those Tier 1 and Tier 2 thresholds. Maybe an automatic mechanical shutdown had to kick in to prevent a spill, or the system temporarily breached its safe operating limits before automatically correcting itself. These are the process safety near misses. They are massive warning signs, and monitoring them is absolutely essential for fixing vulnerabilities before they escalate into an all-out catastrophe. Let's move to our final section, building a safety culture. Okay, so we've reviewed the disasters and we've analyzed the near misses, but how do we prevent them? These steps outline what we call Tier 4 indicators. If Tiers 1, 2, and 3 are like looking in the rearview mirror at what already went wrong, Tier 4 indicators are looking forward through the windshield. They measure the proactive operating discipline required to keep the environment safe in the first place. We're talking about demonstrating how well inherently safe engineering designs are executed, tracking equipment maintenance, completing process hazard evaluations on time, and making sure the workforce actually finishes their required safety training with verified skills. It's all about auditing that day-to-day diligence that keeps the high-pressure hydrocarbons flowing safely inside the pipes. Tying all these data points back to the ultimate goal, a proactive culture is absolutely non-negotiable if you want to prevent fatalities and mitigate operational downtime. The SASB standards really emphasize that management systems have to integrate safety through the entire value chain. You have to engage and empower employees to safeguard their own well-being and, crucially, coordinate that safety culture with the contractors and subcontractors on site. By preventing severe injuries and avoiding those catastrophic Tier 1 community evacuations, a company fundamentally protects what we call its social license to operate. So, by using the specific SASB standards we've covered today, the refining and marketing industry is held accountable in a truly measurable, transparent way. Investors, regulators, and the public can look at these standardized disclosures, from the total recordable incident rate all the way up to Tier 1 process safety events, and get a real apples-to-apples understanding of how well an organization manages its absolute most extreme hazards. As you think about how these organizations evaluate risk, documenting everything from a minor chemical spill to a major community evacuation, I want to leave you with a thought to chew on. Can a company truly be profitable and truly sustainable if its safety culture treats catastrophic risk as just another cost of doing business? True sustainability isn't just about the environment, right? It's about the very lives of the workforce running the operation. Thanks so much for joining me for this explainer, and I hope this deeper look at the anatomy of safety completely changes the way you look at corporate accountability.